This is a review for Algebra 1, Topic 1b. Your test will have 12 questions and cover 3 separate sections. So that means that there are 4 questions a section. I'm going to review 2 per section. For section 1.4, we were talking about literal equations, and that is when we are asked to solve for a certain variable. So in this equation, we have 6x minus 5y equals 12, and we want to solve for y, which means I want to get that y alone and by itself. So before I can do anything with this minus 5y term, I have to undo this positive 6x. I'm going to undo positive 6x with a negative 6x, so I will subtract 6x from both sides. Those will undo each other, and I will bring down my minus 5y. And now what you're going to see is 12 and negative 6x are not like terms. They cannot be combined. This term has a variable, while this 12 does not. So since I cannot combine them, I just leave them as 12 minus 6x. All right, from here we still want to get this variable y by itself, and currently it is in front. It has a negative 5 in front of it. And they are right next to each other, so that means that multiplication is happening. So to undo multiplication, I'm going to divide by that negative 5, and that's going to undo each other. And we're going to be left with that y by itself like we want. And what I do to one side, I have to do the whole other side, not just the 12, not just the minus 6x, but the whole other side. So now I'm going to look at that, and I see that in my numerator, which is the top, numerator north, I have 12 minus 6x. In my denominator, the bottom, I have a negative 5. Fractions are division. So I have 12 minus 6x divided by negative 5. And you guys, I'm going to just completely leave that as a fraction of 12 minus 6x over negative 5. I'm not going to combine anything. I'm not going to do any calculations. My answer and how I solve for y is equivalent and equal to 12 minus 6x divided by negative 5. And that's how I would type in my answer. The next one I'm going to review, I've already kind of worked out. So what I want you to do is I want you to pause and try to do number 2. J equals BS plus 5, and it tells you to solve for B. And now let's go through it once you've tried it. I want to solve for B, so I need to get this BS by itself, and before I do that, I'll need to move that 5. So I can undo plus 5 with minus 5, and I subtract 5 from both sides, and that leaves me with J minus 5 equals BS. I again want to get this B by itself, so I have to undo that S. They are being multiplied because they're right next to each other. So the opposite thing to do will be to divide by that S on both sides. And what we are left with is my left-hand side, J minus 5 divided by S equals B. Notice how we just leave that. There's 2 variables there, 1 number. We're not going to combine anything. We are just going to leave them. That was section 1.4. Now 1.5 was about solving inequalities and graphing the solution. So when we solve an inequality, we do the same steps as solving in equations. We just have a couple special things to remember, and we'll review those here. So if I wanted to get that x by itself, it's got a negative 8 in front of it, so I'm going to divide by that negative 8 on both sides. Those are going to undo each other, and I'm going to be left with x. And now here's that very special thing. When we are dividing by a negative number, aka the number we're dividing by is negative, that means we flip that sign around. So that's actually x is now greater than, and then 64 divided by negative 8 is negative 8. So instead of our sign being less than, it is now greater than. And now we want to graph that on a number line. And there's 2 ways we can put a dot on a number line. We can do an open circle that looks like this, or we can do a closed circle that looks like this. We use open circles for our less than or our greater than. closed is when we have less than or equal to, greater than or equal to. So since this is just the greater than symbol, we're going to do an open circle at that -8. And now we want to figure out the numbers that are greater than that -8. So thinking about which direction are the bigger numbers, that's going to be to the right. So I shade to the right and I draw an arrow to tell me that it keeps going. Everything to the right of -8 is greater than -8 and is my solution. Now try this one kind of on your own. We want to solve this inequality. Try to do the first step. And that means I'd have 2x plus 4 is less than, if you distribute, that's 2 times x, and 2 times -3 is -6. Now if I want to solve this inequality, I want to undo the variable. So I'm going to look at this 2x here. And I want to do the opposite thing. The opposite of positive 2x is -2x, and I do that on both sides. 2 minus 2 is 0. Those had to be 0. They're gone. So if I bring down what I have a statement that says 4 is less than -6. Think about that statement. That is saying, and I quote, that is saying 4 is less than -6. Is that a true or a false statement? That is false. 4 is not less than -6. So if we have a false statement, then we have no solution. And that was some of our options too in 1.5. We could have true or false statements based on what the statement is. All right, 1.6 was compound inequalities. And compound inequalities just meant we had more than one, and we had two types. We had and or inequalities. The first step in either type is to solve them separately. So what I want you to do here is pause and solve each equation separately. Great. Now check your work. If you solve both equations separately, you should end up with x is less than -5 or x is greater than 4. And that or statement truly means I can be this option 1 or I can be this option 2, but I cannot be both and I cannot be in the middle. And we graph those on a number line. So again, we follow our open and our closed circle, and we do them one at a time. So we want to do x is less than -5. Since that is just less than, and it has no or equal to, it'll be an open circle at -5. And what are the numbers that are less than -5? Are they to the right or are they to the left? They're to the left, so I shade out to the left and I draw an arrow. Now I want to do x is greater than 4. Again, it doesn't have the or equal to symbol, so that's an open circle. And what are the numbers that are greater than 4? Are they to the right or are they to the left? They're to the right, so I shade to the right and I draw my arrow. The or graphs should kind of look like this one all the time, where you have two numbers that you're graphing and you're shading to the outside, not into the middle. All right, our next type was an and graph. So pause. Still the first step is to solve the equations. So solve them both and then check your work here in a second. If we solve them both, and we made sure to remember that if we're dividing by a negative number, we flip that sign around. We should have ended up with x is greater than -5 and x is less than 4. And means both. We are going to be in between these things. We graph them on a number line. So again, these happen to be open circles because we do not have that or equal to line. If we did, they'd be closed. So I have an open circle at -5, and I want the numbers that are greater than -5, that's going to be to the right. Okay, so we shade to the right. Now I'm going to look at x is less than 4, and it's going to be an open circle because of that less than symbol. And I want the numbers less than 4, that's going to be to the left. Notice how those are just the numbers in the middle. So we shade the middle. And problems are really like in between problems, where you are going to have your answer is in between two numbers. And sometimes we can flip around our first inequality and we can write it truly where the x is in between. That'd be negative 5 is less than x is less than 4. If we bring these down and if we flip this one completely around, notice how that greater than symbol becomes a less than symbol, because now the negative 5 is on the left and the x is on the right. It means in between negative 5 and 4. And that is a little review of topic 1B. This is the end of topic 1.